Now we're going to look at differentiating inverse hyperbolic functions. We start off with y equals r sine x. How are we going to cope with this? What's the first thing that we ought to do? Well, it means basically that sine y is equal to x. Now I can use the chain rule to differentiate. Differentiating sine gives me cosh, so I have cosh y dy by dx is 1. This gives me that dy by dx is 1 over cosh y. How can I get that back in terms of x? Well, I've got sine y is x, here's cosh y. At this point, you need to remember that cosh squared y minus sine squared y is 1. And therefore cosh squared y is root 1 plus sine squared. Now I hope at this stage that you're all shouting at me to put in plus or minus. Think a little bit about cosh y. Cosh y is positive. So we don't need plus or minus. Cosh y is positive, therefore we must just have plus. So it's not being careless or slack, it is all logical. Now we get that if we differentiate r sine x, we get 1 over root 1 plus sine squared y. Sine squared y is x squared. Now you can do that for all of the inverse hyperbolic functions. And in each case where you need a square root, there is a perfectly good argument as to why you take the positive root. So we're not just ignoring the minus, there is a good reason. Here we have the inverse hyperbolic functions. R cosh x, x has to be bigger than 1. For tanh x, we have to be less than 1, and so on. R tanh x and R coth x do look as though they have the same derivative, which in a way they do. Minus 1 over x squared minus 1 is 1 over 1 minus x squared. But the domain for R tanh is mod x less than 1, and the domain for R coth is mod x bigger than 1. So in that respect, they are actually different functions. Let's just remember the top one. R sine x, when we differentiate, is 1 over root x squared plus 1. Let's write it down before we forget it, that if we differentiate r sine x, we get 1 divided by the square root of x squared plus 1. So in this question, if I'm looking for dy by dx, I'm just going to use the chain rule. There's no need to put sine y equal to root x squared plus 1. You could get it out that way, but this is going to be just a little bit quicker. R sine x differentiates to 1 over root x squared plus 1. So this differentiates to 1 over the square root of root x squared plus 1 squared, just to be a little bit pedantic about it, plus 1. So that is the first part of the chain rule. Now we have to differentiate root x squared plus 1. A half x squared plus 1 to the minus a half times 2x. And so in this case, dy by dx is going to be, the 2's cancel, The x stays on the top, and on the bottom, if I square root x squared plus 1, I get x squared plus 1 is x squared plus 2, and here I've got root x squared plus 1. So this is going to be root x squared plus 2 times root x squared plus 1. Didn't need such a big line. Let's put a shorter one in.